Hey guys, so today I just thought we'd take a quick look at these positive temperature coefficient or PTC thermistor. And I've actually used these for little hand warmers or pocket warmers before with some lithium ion cells. It's probably easier just to do it with like a power bank or even a smaller, a little 18650 do-it-yourself power bank, something similar to this on eBay. Just don't be in a hurry for them. It takes a while to get them, like most things. But of course you can hook up a battery. You could use the flat packs, which would be more, probably be a little bit more convenient. Have the little battery pack just slide in your pocket, But I've typically done like anywhere from 8 ohm to 10 ohm resistors. My favorite thing to do is actually a PTC, and I'll show a little demonstration hooking to a USB cable if you just wanted to make something real easy and portable. But of course, a PTC thermistor, the neat characteristics about it is the temperature gets hotter and hotter, the ohms of resistance increases, so therefore it's not likely to overheat on you or draw overcurrent. So just as a protection device, kind of like a resettable fuse in some circuits, we can use this with like a 4 or 5 volt circuit. Since I have picked these 10 ohm up to 110 volt rated PTCs, and I just had a few here because I like to buy them by the 10 or by the dozen or so, different ohm ratings and things. But these in particular, 10 ohms is nice because you could even put them in series if they're a little bit too warm, and of course for more load and more of a pull on your battery pack. But you could put them in parallel. You don't really want to use PTCs or NTCs in parallel. But in this case, with them being separately, just regulating for little heaters, it probably wouldn't be a big deal. Probably be the only application I'd ever do it in. So here I'm just simply taking the little connector kit that I have and hooking up onto a USB cable. Just to show the PTC, you could either hook it to a connector or just slide it straight in the connector itself. I've actually soldered in a resistor with the connector as well. We'll look at it later, but as we see here, the current draw is pretty stable, somewhere around 1/3 of an amp. And we'll get a little thermal imaging up here too to show, with just one and not being in series, it could be a little bit warm. But of course we wouldn't let that touch the skin. We would either have it wrapped in some little fiberglass sleeve, or we can take some 3M glass cloth tape and wrap it up and then put it into like an aluminum heat sink. So here, just taking a little key ring for the spring action and put on there, we do see a temperature difference. So just showing that the heat sink there can make a difference in the heat dissipation. And now we just plug the 10 ohm resistor up. We see that it's pulling close to 1/2 amp. And of course, it's just going to stay roughly 10 ohms. It's not going to change based on heat or current. It just is what it is. We'll let this heat up and then we'll do a little thermal imaging on it. So here's the thermal imaging on that 10 ohm resistor. Because it is already got the little ceramic coating, you slide it inside your heat resistant sleeve there and a little bit of tape. It could be a makeshift little pocket warmer or hand warmer for you. So both a little bit hotter than what these are claiming to be. And of course we could adjust that. We could go with 20 ohm, or like I say, put these in series. You could probably go with more 15 or 20 ohm on the resistor. There's different ways to do it as a makeshift, but I just thought we'd actually look at these two pocket warmers or hand warmers that I bought and just see what the difference in the technology is. I didn't know if they use a little NTC or they use their own little resistive heater on circuit board or what. Well, ThermaCELL heat pack comes pretty neatly packaged. Low, medium, high, just as stated here. 106, 110, 116. pretty neat. 500 milliamp to 1500 milliamp. I imagine the battery pack's got to be bigger than that to have the capacity they say it does. That's just actually for the heat settings itself. Almost like a phone case. Comes with our USB charger. And a pretty decent little power brick here. 2.1 amps on USB 1. 1 amp output on USB 2. That's pretty neat. So it does say it has a 3300 milliamp hour battery. So we press our button for low, medium, or high. Up to 4 hours of charge. All right, let's look at this little cheaper Hotpod, double-sided Hotpod hand warmer. The interesting thing about this one is it's also a USB power bank. Well, I knew that this just came in a little padded envelope. Well, we'll take a look inside of this one. It wasn't packaged too well. We'll just go ahead and skip ahead and look inside since this one was already giving it to us here. Well, that's pretty neat. It's just a little trace here. I was gonna say mica, but it's really like Kapton tape covered. So it does have both sides. That's neat. And let's go ahead and get an ohm reading on that. Probably less than 10 ohms. I would imagine electronically is controlling it. Yeah, around 2. Yes, around 2 ohms. That little bump, if you can see it there, that's going to be a thermistor on one side feeding back. So they have actually soldered instead of spot welded onto the lithium ion 18650 cells. Long lin. Says a 1500 milliamp. Now I have on my channel showed you can solder really quickly and cool them off and do it fairly safe, even though I know it's not recommended. But I never thought I would see a manufactured product do that. But anyway, I've done it to get by. I'd rather spot weld if I could. There's our on off button. Our heater pad going from heater 1, heater 2. So very small power wire indeed. I mean, honestly, the last for hours you would expect into the milliamps or no more than a half amp load. Hopefully you can see that on camera. Those chips are no name. We got 6 LEDs here. It says blue and red. So it looks like blue for charging and maybe red for the heat status. We'll find out. Will this power on? Yep, there it goes. It did power on. If I hold it down, there we go. So it is. Oh yeah, I can feel it. I can feel it on this side for sure. So this one comes on high. You can see all 3 red. I hold the button down again. We drop down the medium. Hold it down again. We go down the low. We see our charging port in, our power bank 5 volts out. No information or ID on the chips at all. I mean, it's still a neat design. And that's just up against plastic, which I would have thought it would have had at least some kind of foil tape or something over that. But they do have the Kapton tape, so I guess that's fine. I'm going to cut this off now. It does have a little notch here for the battery. It doesn't have a notch forward, which is odd. So they're relying on the board to keep this side in place, which will be fine, except for the little RT1, the little thermistor feedback is getting pinched between the battery. And there we go. Oh no. That may have happened during shipping as well. One thing I didn't really notice when I took it out of the package, because it was broken, that took my attention, but where they show the nice little Hotpod across it, it actually doesn't have any writing on it whatsoever. But I'll give it its credit. It definitely comes on and works. This is the specs. Says it can output up to 1.5 amp. And nothing on the back. Now we'll take a look at this one. So this one, you push it. Okay, it gives us one blink. It don't have but one LED, but it's multifunction. Press it and hold it again, and we get two blinks. So we're on medium. Push it and hold it again, and we get three blinks. So we're on high. So it works very similar, but it's opposite. This one comes on in high and toggles down to low. This one comes on low and toggles on the high, which kind of makes more sense to me. I think they're both. If you hit it again or just hold it down, it cuts off. Well, that's cool. Let's see if this indeed is like a phone case. It is. How about that? That's pretty good protection there. See the little catches here. Yep. The little catches are pretty visible. There we go. Really just needs a fingernail. Wow, that's neat. A very nice 3300 milliamp hour battery there. Nice connector. Even though this is your higher end product, it lets you know the chip numbers. How about that? There's our LED and our little push button here. So this one does not have the power bank ability, but it is a really neat little pocket warmer. That's just actually padded protection. There's a little thermistor there on board. So this one's got a nice little rubber mat on it. Just trying to see if one side's easier to peel up than the other. Well, look at there. Look at those traces. That is really neat. So it looks like here and here, got a coating on it. Yep, about 3.84 ohm. Going across this, going all the way around, all the way back to there. They built that into the circuit board. I really like that a lot. You could even run this one a little bit more compact. You would just have to have something to push your button there. Well, kudos to ThermaCELL. That is a really neat little heat pack. This one's really not that bad either. Well, I tell you what, to compare them, I'm going to put them on low, because low says 107 and then 118 and 131. So low is the only one that's very, very close on them. I could do medium on this one and high on this one, but we'll just do low on each one. And I just want to come back with my thermal camera and just see roughly, you know, what the surface temperature is. We'll just take a quick look and we'll be right back. So here's the thermal imaging of the ThermaCELL heat pack on low, after giving it a few minutes to run and normalize. And now the little Hotpod hand warmer on top. Now the bottom. So just a comparison there with them both on low, where the ThermaCELL said it's rated for about 106. And the little Hotpod says about 107 on low. It is neat how the Hotpod does the top and the bottom. That's pretty neat. So back now with this fully charged, and at fully charged we at 4.15 volts. I want to put this across my load tester, my constant current load tester or battery performance tester. Just see how many milliamp hours we can get out of it before we drop down to 2.7 volts. Okay, back now with the cells up so I can connect them easy. We have 4.1 volts. I'm going to go ahead and reset the data from my last test. As soon as I cut the current up above a half an amp, it should start the test. And there we go. I'm going to let this test run right at an amp. I think that's a fair test with two being in parallel. That should be fine. That should be somewhere around 500 milliamps per cell. And we'll just see what the capacity of these cells are. So we'll be right back when it finishes. So just short of 2500 milliamp hours, pull down to 2.7 volts. So that's actually that's better than I thought the capacity was going to be. So they are a little bit short of the 3000 combined, but still not terrible cells. Next I'm going to put this back together, and I want to check the USB output the same way. So far over an amp hour, and we down to 2 out of the 3. If you can tell that on camera, it's a little blurry. 2 out of the 3 LEDs there. So it's actually doing better than I thought it would. So 1.5 amp hour. Still shows like 2. So we do see that this is really just an on-off control. We can see here with a meter, it's just going to pulse off and on, kind of like a thermostat, instead of right at 3.2 volts on the on state, and then it's going to cut back off. So apparently it's using that thermistor on the other side to cut on and off instead of being a pulse width modulation. So that does work differently than I thought it might. See if we can see how this one does. So I got this on half a second per division because the other was just on and off. It looks like they both just use the on-off control based on that thermistor. I don't see neither one of them doing a duty cycle or pulse width modulation. I just really thought if you bought one on the consumer market that it would probably be designed to have some type of pulse width modulation control, just pulsing the heater on and off at a different duty cycle for different heat mode. But I guess they're just using that thermistor, both real similar, just using that thermistor to regulate the temperature. So they use a real similar technology. It's kind of surprising. No comparison in build quality on these, that's for sure. Lithium-ion cells can just really make it easy to have convenient things or build something convenient. But I also wanted to compare a way that some are done commercially available, and just thought we'd take a look at how neat they're designed and how well they work. So don't forget to comment down below if you got any questions or comments about the video. Also check out the video description, where I'll have some links to some of these things, including the PTCs and this little connector kit if you're interested, and as well as the heat pack and the Hotpod. So I also have a link in the description on my videos of some tools and things on the bench that I really like to use that might come in handy for you. If you like this video today, please like, share, subscribe, and thanks for watching.